Welcome to The Curious Developer. I am Jesper Peterson from KDAP, and you are in the middle of a mini-series on AI in development. How is it all working? And up until this point, we've talked about Qt, and we talked about, more specifically, Qt Creator, how to set it up. But now I have lots and lots of questions on the models. But the thing that keeps me awake at night is, with all this talk about models, is Jan dreaming in about Right Said Fred? Welcome, Jan. How are you today?
Hello, Jesper. I'm fine. You seem to be having a lot of sleepless nights. I can tell you I'm sleeping much better.
You know Right Said Fred, right?
No, I don't.
These young people, they had a hit in the 80s that went like, I'm a model, you know what I mean? I do my, and then you can Google the rest.
I feel there is some KDAP lore hidden in there, and I think I know it. Okay.
So, models. Bigger is always better, and cheap is better than expensive, and open source is better than commercial, and so on and so on. I have a lot of questions to figure all this out. And even the Qt Creator plugin, does it come with its own model, or how can they be specifically doing good with QML? There's a lot of questions in here. Are you ready?
Yeah, I'm ready.
Okay, let's start with the models. They come in lots and lots of different sizes, and it's like, I don't know, you see these boys bragging about whose dad is the stronger when you read the news about the next generation model from OpenAI and Google and whatnot. And it seems like the only thing that counts is the size of the model. The larger the model is, the better it is. Is that true when it comes to programming? And let me just ask another question in the same vein. You showed me that I needed to specify two different models, one for code completion and one for chat. Why is that?
Okay. Those are great questions, and I will start answering or replying to you with the sentence that it depends. Well, you kind of saw that coming, I assume. So the current research paradigm is that bigger is probably better because the assumption is the more parameters you have and the more data you have, those two things are closely connected when you train models. The more chances there for your model to build good abstractions and to be able to do more tasks and be able to do more tasks better. So yeah, this is where the research direction is currently heading, because many people are hoping that if we make the models even better, so bigger and more data when we train, that they will be able to do even more things, and maybe that super intelligent thing is coming around the corner. Whether that's actually going to happen or not is a debate, and it's like there are like positions in one direction or the other, so we're not going to go there today. But yeah, so this question of is bigger better, currently the research goes in the direction probably yes. But when we talk about programming and when we talk about specific tasks, it's not that clear. Specifically, when you try to teach an LLM a new programming language, you often don't have that many examples of that language. And the way that you train a model is you show a lot of examples, and then after some time and showing the model a lot of examples, it will hopefully be able to generalize what it's seeing and be able to, I don't want to say understand, but reproduce the language that you've shown to the model. So now if you want to train a model to understand or reproduce a new language, you probably don't have a lot of data available. And in these situations, it's often easier to train a small model. And not only because you have very little data available, but also because it's cheaper for you to train the model and run the model. You need less GPU memory, you need less power, you need less training cycles, you need less disk space. So in many situations that we try to apply models, it turned out that fine-tuning small models or training small models can be the better way forward.
So let me understand you correct there. When I hear about training models, I see these gigantic fields of endless rows of computers that does training on models. But that's a training with a billion trillion parameter models. What could I, possibly not on my own computer, but at least in my own few servers with lots of GPU, could I, is it called fine tune my models so that they would know my programming languages better? Or possibly even programming language in singular?
Yeah, you can do that on a single GPU, and many people are doing that already. In fact, that actually the models that we have at the moment, like these super large models from OpenAI or from Google or other companies, they are the progression of people training small models, realizing that works well, and then just scaling them up. So that's why this idea of if it's bigger, it's better has so much traction, because for the past months and years, this has been true, more or less. But it all started out with small models that you could train, and you can still do that. So for example, the CodeLlama 13b model that we also showed in one of the past episodes is one that you can fine-tune with rather small GPUs. Also because the fine-tuning mechanisms often do not train the whole model, but they train like a small adaptation of the model, or they train an adaptation to add to the model. And that is usually cheaper, and it yields good results in general. Now your question aimed at, can you do that for one specific new language? And the answer is yes. And this is exactly that Q Company has been doing. So they took the CodeLlama 13b model, picked some QML examples to train on, and then they fine-tuned or trained a CodeLlama 13b model, and then also published it. And this is why in Q Creator you can select a CodeLlama 13b QML model for code completion. And as I was saying, that if you have only a small amount of data, it's often easier to fine-tune a small model, also because it's cheaper. So this is the path that Q Company seems to have chosen here too. They took a model that is easy to train with some QML examples, fine-tuned it, and then they published it on a service where you can publish models, and you can now download it and run it on your own systems. Again, with the normal, like, for example, I could run it on my MacBook, but we also run it on 4090 GTX GPUs.
Okay, and one thing I'm still struggling with is these models, couldn't I just teach it C++ and then QML, and for my SQL usage also teach it a bit of SQL, and then I have fine-tuned with these three things and I'll be all set? Or will it just be confused and think that SQL and QML, they both end in ML, is the same language?
Right. So for smaller models, and also in the experiments that we've been doing at KDAB, it turned out that you cannot fine-tune those models for many use cases at the same time. What worked well for us was to fine-tune it in some language, and then maybe QML, let's say. And then we realized that the models would lose their ability to do chat conversations, because also having a chat conversation or doing code completion, this is also skills that you train onto a model. And if you fine-tune models too strongly into one direction, they can start unlearning another ability that they had. So striking a balance here in how many skills you fine-tune into the model is one of the skills that you as an AI engineer or LLM engineer have. And what seems to work rather well is that you fine-tune it for example, chat completion and one specific language, or you fine-tune it for code completion in one specific language, maybe two, maybe three, depending on how you train and how much data you have available and what specific model you train.
This kind of makes me wonder again about some of my coworkers, whether they are really AIs, or because they seem to have lost the ability of chatting once they got to learn programming. No mentioned, no named, no forgotten, or whatever you say there. So we have these gigantic players in the market, and you told me that there are smaller models that I could use. So if I'm on a budget, say I'm a student and I can't afford a $20 a month license for whatever, can I just download one of these smaller models, put it on my preferably MacBook, and then and the reason why I say preferably MacBook is because you tell me that MacBooks are much better when it comes to this kind of thing. Maybe you can elaborate on that for a second, and then answer the question on, is there a cheap option, or do I need to find a way to cough up $20+ a month?
Okay, so in terms of MacBooks, the thing with MacBooks is that all the Apple Silicon MacBooks come with on-chips graphic cards that are accessible for CUDA, so for the library that is used to run most of the LLMs. And that makes MacBooks a very easy development platform for this. Also because they have unified system memory, so the graphics card can use all of your RAM in order to train LLMs. And one of the constraining parameters for working with LLMs is often the available GPU memory that you have. On the other hand, the best performance on inferring and training LLMs in terms of speed, if you just look at how quickly can the GPU process tokens and can process an LLM, basically, this is not necessarily Apple GPUs. So the NVIDIA GPUs there's a reason why those are the GPUs that are being used in data centers, because they work on different scales. But for your at-home tinkering, Macs provide a nice platform, especially if you already have them. But using a dedicated graphic card in a tower PC, for example, works well and probably better because you can buy more like faster GPUs for them, right? Okay, so this was the macOS part, or the Mac platform part. And then the other direction is, remind me of the question.
Well, is there something for those on a budget? Or do they all need to buy expensive licenses with OpenAI or the likes?
That depends on what you need specifically. So the smaller models like CodeLlama, they will not provide as good replies and as good answers on all the topics as do the large models. And if you just want to have a model to chat with and you don't want to worry about setup and everything, using one of the available models is easier, especially since there are many free tiers, and ChatGPT, for example, is available on a free tier and it works very well there too already. Now, if you want to fine-tune models, then if you maybe even already have a GPU, one of your easiest ways is to go with different Python code versions that are available on the internet to start fine-tuning and learning those abilities. And for that, it's easiest if you just use a GPU that you have available.
And if we move up a bit from those that are students or on a very tight budget anyway, somehow, and move into people that can afford the $20 a month or whatever they are, these all comes, at least those that I've seen, with a maximum amount of tokens that you have available. I'm wondering am I gonna use all my tokens before I even has completed my first QML statement or asked the first QML sentence, or what is a token and how does that relate to things?
So in order to explain tokens, let me do a little bit of LLM technology conversation first. So if you read a sentence, you will look at characters, and the human brain will very often already start recognizing chunks of words, syllables, or other sections. And then we look at words. The way that LLMs read this is not character by character, but there is a way that this is called a token, where they just take a few characters and kind of merge them. So instead of, for example, using ASCII as an encoding, they use the special token encoding that they have. And different LLMs use different tokens or tokenizers. This is the term for the piece of software that creates tokens from a text document. And you can you can create a text document again from the tokens, right? So there's a correspondence between that, obviously. And so when you look at a text that you want to put into an LLM, you will first convert the text into tokens, then give that as input to the LLM, and the LLM will produce tokens again. So those tokens is something you need to decode into text in order to work with it. Now, the next question that people might ask is, how many characters or words are a token then? And this I cannot answer very well, because this depends on a lot of factors. One is the specific LLM and the specific tokenizers that is being used in the specific scenario. But also this depends on the language. For some languages that are more common, there is a different ratio of characters to tokens than for languages that are less common. And when I say common, I mean in the data that the LLM was trained on. Because I can train an LLM only on German, which will lead to a different token to character ratio than when I train it on German and let's say Japanese and Chinese, because then you have like different languages, many different languages that you want to get into the same token space.
If I have fine-tuned my models on, say, C++, could I expect that the word switch, for example, from a switch statement in C++ could be just one token then?
Yes, in theory, yes. I haven't looked at the exact details and how programming LLMs use tokens exactly, but that is something that could happen, yeah.
Okay. So what is the amount of tokens that I have in these professional setup compared to?
Let me answer this in a different way round. So I was saying I cannot exactly tell you how many characters, what the character token correspondence is, but for programming and English language text, you could very, very, very roughly maybe calculate with 4 characters per token. Just if you need like ballpark estimates. But again, this will vary on the model, the language, and everything. Now, if we go back an episode, we have done some LLM work where we use the Qt AI assistant plugin in QCreator to try out what's available and how. And yeah, we worked with ChatGPT, and I looked up how many tokens we used for that, and that was about 11,000 tokens for the amount of work and queries that we did in that context. So that might give people a feeling for how many tokens they use when they work with ChatGPT. And now, in terms of what is the running cost of something like this, the API that we're using from OpenAI for this plugin specifically, it doesn't work on the I pay $20 a month and then I get that many tokens kind of billing method, but it's just billing per token. So you pay a certain price per token. And that depends on which model you use, because larger models will be more expensive. And also OpenAI is probably doing some load adjustment where models that are more frequently used are available more, so they can get scale effects and they might be little bit cheaper. So there is a lot of calculations going on probably at OpenAI side. But this you could use to calculate maybe what could be your daily usage of tokens, and then what can you expect in terms of cost that is coming out of your API usage. And maybe as a side note, so this is not only OpenAI, but for example, Anthropic also offers similar APIs for their models, and Google will do similar things. So this is a model that, or a pricing model that is being used across LLM providers.
What kind of world are we living in where you're actually paying for how much you're using of something? That's like...
Well, I mean, in cloud computing, this is a common thing.
So I'm just... can you still give me a ballpark? Are we talking about if I sit there and I talk a bit to my code and I have it complete my code, am I spending $1, $10, $100, $1,000, $1 million? I can make even bigger numbers if you want to, a day.
Okay, I don't need bigger numbers. So also the session that we had, I forgot the exact amount, but it was in the 2 to 5 cents, dollar cent amount on cost.
Okay. In QCreator, we had a few different options of models that we could choose from, if I remember correct. Can you elaborate about both in QCreator and in the larger market for AI assistants? What are the models in general that we have available?
Oh, wow, that's a tall order because this keeps changing, and I will definitely forget one of the large players when I go there now. But I'll try to give some idea. The most well-known is OpenAI with their ChatGPT models, or the GPT models. And they've been, let's say, they've been the first to really hit the media court and like have this huge hype around them. And then many players started following up on that. Then there is Google, who have the Gemini model space, where they have some models that they do not make public and some models that they do make public. So maybe this is something that I should also explain. So when I say some models are public and some are not, meaning that the model weights, which is the important part about those models. If you want to run a model yourself, you need the model weights. OpenAI is not publishing the model weights of their current models. And also Google is not publishing the model weights of their large models. But Google, for example, is publishing smaller versions of some of their more recent models as weights so that people can run them on their own systems. Then there is Meta, so the company that owns Facebook. And they train a bunch of models that they call Llama in various versions. And Meta is publishing all of those models, so the model weights, so that people can run them by themselves. The more recent models that they have trained are so large that it's not realistic that you just host it on your system. But for example, Code Llama or the Llama 3.1, 3.2, 3.3 models, there are small versions that you can just run on your systems, or for example, on my MacBook, or the GPU server that we have at KDAP. Then there was a model that, like a Chinese model that made waves that has kind of disappeared out of the news cycle again. So as you're seeing, there is a lot of different models with a few larger players that are positioning themselves in different ways in this whole LLM space.
Okay. One thing that always comes up when you talk about AI is how about my data? Is that going to be leaked when I'm sure that my YouTube video has been gone into the training, which is why the training data must be totally awesome. I wonder when I'm sitting there coding my own stuff on secret stuff that cannot be leaked to the rest of the world, and I have AI assistant development tools running. They must obviously upload some of my code. Is it uploading my whole code repository, or what is it uploading, and will it remember? What are my considerations there? I know this is a topic that we could spend a whole day discussing, but just scratch the surface for me.
Okay, so if you use models that you're not hosting yourself, so for example, ChatGPT or Google Gemini, then you will transfer code to an external API. And that means you're under the API usage terms that you have with that particular company. If you host all of the models that you're using on your own servers, you also kind of apply, like you need to confirm with the terms of that hosting apply to you, but those are usually your own terms. So that's like a different question. And which parts of the model are being sent to which parts of your code base are being sent to the model? That depends on the plugin that you're using. I haven't looked into the details of the AI system, also because the code isn't public. From a little bit of poking around, it seemed that, for example, this code completion model looks like 20 lines up and 20 lines down or something. Maybe it's 30, right? Don't like the numbers, let's say they don't matter, but it looks some lines forward and backwards, copies those and sends them to the model to ask for a fitting prediction in the location where the cursor currently is. So the Qt AI assistant for code completion looks a little bit up and down in the code file. But for example, Copilot in Visual Studio Code, depending on in which mode you use it, will look through your whole repository to find pieces of code that are interesting to the specific task that you're currently looking at. The most simple version of this could be take all the files that are currently open in the editor and send those files with the request. Or do some general pattern matching on code that is in your code base that looks similar to the code that you're currently editing. So depending on the plugin, a lot more code could be in play when a certain request is being made than only the code that you're currently looking at. And this, of course, is something that you want to consider when you use external providers for models. When you have sensitive code base, when you maybe have customer code bases that you might need permission to use specific model providers.
This brings up a whole bunch of new questions, but let's take that in a separate episode, namely whether the GitHub Copilot is even a previous step, or is it a competitor these days, or whatever. But we'll take that in a separate episode. Just a final thing when we talk about models, something that I hear a lot that I wonder how fits into all of this is a word called foundation models, and then training on top of those. Can you help us a bit with that?
Yeah, sure. So a pattern that has been established in training models is that you first train a model on a lot of text. And this is like many different languages, many different programming languages. If you train multimodal models, you might want to add image material or whatever it is. So you create a model that hopefully, while you train it, learns a lot of abstractions. But those models aren't fine-tuned for specific use cases. So after you train that, you train in a second phase, you fine-tune the model in order to solve specific tasks. And most people and most companies will not have the resources to do this training of foundational models. They usually have resources to do the fine-tuning, but this whole parallel computing in order to train like those huge foundation models, that is something that most companies currently will not afford or want to afford. But for that, they can reuse models that, for example, Meta is publishing.
Thank you very much, Jan. That was very enlightening. We'll have to talk a bit more about the security issue of all of this. And I really would like to know what is in store if I want to run these models on my own silicon, or at least in server farms who promise not to do anything but bring bits forth and back. But that's for next episode. See you then.
Okay, see you then.